Okay, the next one we have there are two lines that are right next to each other. And you might know this one as well. These are parallel lines. Okay, there could be points in these lines, or I'm just going to make it simple and label them with lowercase cursive letters. We have line N and line L. So when we flip that up, we do have a way to notate this, that these are line L and line N. Oops, it's line N. These are parallel, and the symbol for parallel is those two lines going sideways like that. The definition of parallel lines are two lines that go in the same direction and never intersect. And then our next one there, we have two lines across each other like that. You might know what this one's called as well. These are perpendicular lines. Perpendicular is a difficult word to spell sometimes. It's a U. Perpendicular lines. Okay, again, we have to put some labels with this. We could put that a G and then an H. So this is line G and line H. Okay, the way we notate that underneath of it is we put G and line H. The symbol for perpendicular is an upside down T. Hopefully you've seen that before as well. So line G is perpendicular to line H. The definition are two lines that intersect and form right angles. Remember, right angles have a degree measure of 90 degrees. Okay, the next one, this might be a new one for you. We have two lines that are on that little cube looking thing. This are describing two lines, and we call these skew lines. Skew lines. Okay, there's no way to notate that underneath your flip there, but we'll just give it a definition and say that skew lines are two lines that are not parallel, and they do not intersect. So they never intersect, and they're not parallel either. So the way that happens is, as you can see on that, they are kind of on different planes going in different directions. We'll talk about that quite a few more times. Next one we have there, we have two angles, you can see. Looks like we have angle 1 and angle 2. These angles are special. They have this ray going right between those things. Let me highlight that. This ray right there makes what we call here adjacent angles. Adjacent angles. And I'll notate this with the angle symbol with an S inside. That means angles. So adjacent angles. Underneath there, there's no way to notate this, but the definition are two angles that share a common side and a common vertex. They're next to each other. I like to think of the word adjacent describing different things, such as you may have had a locker at a school. We don't have lockers here at Richland High School, but you may have had a locker, and your locker had an adjacent locker right next to it. We have a classroom. The classroom that's next to us is adjacent to us. So as you can see there with those adjacent angles, they're right next to each other. They share that common line, that common vertex inside. Next one we have here is two angles again, but these are special in a different way. This symbol down here, this little arc, and that little arc means something. It means congruent. Anytime you see those arcs on an angle, it means they're congruent. So I have two angles here that are congruent. Again, we're discussing this piece right here. The definition of that is an angle bisector. And bisector is a word you're going to see a lot in geometry as well. An angle bisector, or just a bisector rather, a bisector splits something in half. An angle bisector splits an angle in half. So here we have angle 1 and we have angle 2. These are congruent angles. Okay, and underneath there, when we have an angle bisector, it does something with those two angles, like I said. And angle 1 is now congruent to, there's a new word for us as well, congruent to angle 2. This word means, or this symbol rather, means congruent. We'll see that a lot in geometry as well. Okay, congruent to. So angle 1 is congruent to angle 2. Or we could say that the measure of angle 1 is equal to the measure of angle 2. The word congruent means equal, and so if we're talking about the actual measure of the angle, they're equal, or just the angles are congruent to each other. When we have an angle bisector, the definition of an angle bisector is a ray that divides an angle into two congruent, like I said, equal angles. And our last vocabulary word here. See if we can kind of diagram what this, or dissect what this is talking about. We have a line, and there's a point in the middle. I want to look at that point there. that point is doing something to this segment. This segment, what this little symbol here means, and this little symbol here means, are congruent. Okay, we had congruent angles beforehand, now we have congruent segments. And so this point is a midpoint. It's in the middle. A midpoint. Okay, let me describe those points here. I could say it's point A, point M, and point B. So point M is the midpoint. Alright, the way we notate that midpoint there, what it does to the line segment is it makes segment AM congruent to segment MB. We could also say that segment MB is congruent to segment MA. Either way would be the same thing. Or if we're talking about their length, AM is equal to MB. But the definition of a midpoint is any point that divides a segment into two congruent segments. And once again, congruent means equal. Alright, that's all we have for these vocab flips. Hope you guys enjoyed the way we did this. We have a lot more to come. If you have any questions, please bring those to class tomorrow. When that's what we can start with. We can discuss those questions and get going.